Hello guys, this is a tutorial on how to do the Lewis structure for SO2. First step is to identify the number of valence electrons in this molecule. Okay, so we take a periodic table, look for S, which is right here, and we can tell how many valence electrons by the column number. 1, 2, 3, 4, 5, 6. So we have 6 valence electrons for sulfur and oxygen, 6 as well. But if you notice, in the formula, there's 2 oxygens. So there's a total of 12. 2 times 6, 12. Now, if you add it together, 18. So you have a total of 18 valence electrons, alright? Those electrons are the amount we have to play with. Second step, create the structure of the molecule. So you put the less electronegative element in the middle, so which is S. What the? S, okay. Now put O on the side. Next up, you want to connect those elements with a single bond. Alright, so each bond corresponds to 2 electrons. So we have 4, 2, 4 used up. The next step is to fill the terminal elements, which is oxygen. So we have 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so we used up all of our electrons, which is 18. And now we check if the octet rule is met. Okay, oxygen, 2, 4, 6, 8, good. The other oxygen, 2, 4, 6, 8, good. Let's check sulfur, 2, 4, 6. Oh no, we're missing 2 electrons for sulfur. Alright, so let's transfer 2 to sulfur. Alright, so let's check 2, 4, 6, 8, good. Oxygen on the left side, 2, 4, 6, 8, good. Oxygen on the other side, 2, 4, 6, 8, good. So how do we have total? 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, I think we're done. But hold on, we're not done yet, boys and girls. So any elements below the second row may form more than 8 electrons and might be an exception to the octet rule. So it might be 10 electrons, 12 electrons, and sulfur, which is in the middle of our molecule, is in the third row. So how do we make it so that it's the most stable configuration? Alright, this is called formal charge. So formal charge. How do you calculate formal charge? Really easy. So you get sulfur and look for the number of valence electrons, which is 6, right? 6. Then you subtract how many bonds are connected to it, or bonding sticks. So sulfur has 1, 2, 3. Minus 3. Then you subtract the number of lone pairs, which is 2. 2. Okay. Right. 6 minus 3 is 3. 3 minus 2 is 1. Plus 1. Alright. So plus 1. So let's do the same thing for the right oxygen. Okay, so oxygen has 6 valence electrons at a neutral state, minus 1 bonding stick, minus 4 lone pairs. So what do we get? 5, 1. Ah! Stop stopping my. So +1. Right, let's check the left side. 6 minus 2 sticks right there, bonding sticks, minus 4 equals 0. Wait a minute. 1, 3. Right. So as you can see here, we have a +1, +1. +1, +1. And the goal is to get them to 0 charge, because that will create the most stable molecule. All right, so let's try moving these 2 electrons over here. All right, so they still have 8. 2, 4, 6, 8. 2, 4, 6, 8, 10. Sulfur has 10 right now, but we'll talk about that later. 2, 4, 6, 8. So both sides of oxygens are stable. All right, now let's check the formal charge for sulfur now. 6 minus, we have 4 now. 1, 2, 3, 4. And 2 lone pairs. All right, so 2 minus 2 is 0. So good. So 0. Now let's check this right side oxygen. Okay. So oxygen 6 minus 2 sticks, 2 bonding sticks, then minus 4 equals 0. Good. Cool. See? So as you can see, all the charges for each element is 0, which creates the most stable configuration for the molecule. So, but now you can notice that sulfur has 2, 4, 6, 8, 10 valence electrons, and oxygen has 8 on the left side and 8 on the right side. This is due to the exception that I mentioned earlier. So any elements beneath the second row, such as aluminum, silicon, phosphorus, sulfur, chlorine, and below, they can have more than 8 electrons to form the most stable configuration. All right, so that's how you do the Lewis structure for sulfur dioxide. If you have any questions, please feel free to email me at oh, never mind. See ya.